For those that haven't seen me before, welcome. My name is Marco. I'm one of the instructors. I have been kind of in the background for some time now, doing all manner of other things. And actually, it's a good point. If I haven't met you before, it's nice, of course, to see you. But also, I want to be taking things from a background perspective. Um, Actually, this is a good way to start. So before I go any further, as a show of hands, any newcomers to the scene, anyone who's just been joining the academy the last couple of weeks or so, or just someone who's coming into this with a fresh set of eyes. So nice to see you, Sebastian. It's been a while, hasn't it? Otherwise, I'm going to take it as a pinch of salt. Everyone's at least slightly familiar with the theme or how the academy goes. They're in. We're 6 weeks in, Will. Awesome. All right. Well, 6 weeks. You know what? And 6 weeks, even though it feels like a relatively long space of time, actually doesn't give you nearly enough the time to fully appreciate what it is beyond there. 2 days, Darren. 2 days. I think that's a winner. So that's probably started on Saturday, I'm guessing. Yeah. So I have the privilege, I have the honor of welcoming you. These homework sessions are done in such a way that we have people talking and often looking at things from all manner of perspectives from the cloud. And actually, that's what I wanted to bring up today. So we're going to be going back into sort of groundkeeping, actually. So cloud practitioner happens on Mondays. And I wanted to focus in on to kind of plug my own course, actually, of sorts, which is one on cybersecurity and of securing accounts. And I think I wanted to take a step back and more generally talk about things outside the perspective of AWS, because often what happens is we get ourselves really entrenched in this idea that it has to be Amazon, there's nothing else but Amazon, when nothing, in fact, is going to be further from the truth. And that's a hard pill to swallow. It's a big world out there, and it's good to have just a base awareness or a good, a guideline of how the technology is in play. So my goal and the theme for this evening, we'll be talking about things from a security perspective. So let me just get that on screen. Sorry, I've just lost all my apps. And there you have it. Okay, so let me know if you can. Participants, why is that in this way? Tell me if you can see my brand new flashy slide. Yeah, can you see the black screen with cybersecurity on front? Yeah, we can, David. All right, okay. So I'll introduce me. This is my course. Of course, this is something that I just wanted to plug in, but I feel like it's worth going into because I want to be focusing on this week, actually today, especially on securing accounts. So this will be really helpful for newcomers, especially if you're new to the scene or new to IT in general. This will be very, very important because these are best practices, things that we can take forward, be it for websites, be it for apps or the like. And so we'll focus today on what exactly the threats are when it comes to all those accounts, but more importantly, also, what are the defenses we can put in place so that you can keep your accounts safe, whether it's cloud or elsewhere. So, but first I want to consider, what do I mean by security in the physical world, at least, okay? Because when you live in a house, you live in an apartment, live in something, odds are that you have one of these here. A key, okay? A key that's going to let you into a building. Now, of course, that key lets you right through a locked door in this case, or to the habitat in question. But the catch is that if someone else gets that same key, the one that you have in your possession, of course, then they too can also let themselves into that same building. So I want to switch over to the cyberspace where what some of the building blocks of security are that ultimately we can focus on, and exactly what those threats are and what those defenses are as well too. So allow me to propose then that we think about security in two terms, or two forms. So we think of securing our accounts rather in terms of authentication. So authentication really is this process of digitally of me proving who I am. For me, for instance, I am Marco, you're yourself. But that alone isn't quite enough to keep the system secure because, just like I'm Marco, it doesn't necessarily mean that I should have access to your entire home. Perhaps I shouldn't have access at all. Perhaps I should just have access to the entryway or just part of the house or some narrow form of access. And that's authentication, really proving who I am in a nutshell. Hey, Samuel, and welcome to all the people I just see scrolling in there too. So just for the new guys, I'm saying that these are I can think of security really in terms of two sorts, which is authentication and then this closely related topic of security or locations of systems, better known as authorization. Okay, so it speaks to whether or not you should actually have access to something once you have proven who you are, because it's enough to say I'm me, but really, what can you do? Okay, so that I'm Marco, in fact, I should have access to the door. I should be able to go into that place that we just walked through. So then when it comes to securing our account in that case, we don't use physical keys, of course. We more frequently use things like usernames, which of course can be public. And that's kind of by design as well. If you stop and think about it for a second, usernames, they're public by design, okay? It might be a username like Marco, it could be a username like Miss Lion, it could be something more commonly, an entire email address as well. That's more commonly used as a username nowadays, but that's presumably something that's going to uniquely identify you across everything else in the world. And even though that's a public thing, the thing is that you and I ideally don't want to make that private. Instead, we have something else, and that's, of course, our password. So the reality is that nowadays you and I probably have dozens, maybe hundreds of thousands of passwords that, hopefully all distinct, and don't get reused against all those different websites, but more on that in a second. And so it really is just this password alone then that ultimately allows you to authenticate yourself, okay, to prove who you are in that sense, because demonstrates who you are. Presumably, I am the only person in the world that knows the combination of username and email address, which all of us could know, but presumably I'm the only one in the world who knows both of them together, okay, in combination, username and a password. And so the presumption is there that I type in both of those things together, the username and the password, to some app, to some website, that indeed proves that I must be in that case who I say I am Marco. So of course it's not good enough to just have a password alone. As I'm sure you'll probably this evening will appreciate, is that you have to have a particular kind of password, or a good password, a strong password, or something like, which then begs the question, of course, like, what the hell is it? Okay, what's a good password but that strength? And Well, ideally, I would probably start by saying that this password is not going to find itself in a dictionary, like literally a book, a dictionary of English words or some other human language where, why? Because that's going to be vulnerable to something better known as a dictionary attack. And by this, I mean that an adversary, so a hacker, an opponent, a bad actor, they want to get into your account somehow, and they can just start typing randomly used phrases, random words, whatever it is, just to try to figure out what the password actually is. But nowadays, they're a little bit smarter too. So they'll actually use something, and that's known as a dictionary attack. So what they'll do is they'll actually open up a physical book of words in a dictionary, or more likely they'll open up a file on the computer or something. But that's got a whole list of English words or words of some other language as well, which it's their goal, is their intention, very much by design, to go through them one at a time. Try this word as your password, try that word as a password, try all this one, the combination of which, and so on and so forth, until, because if you and I have chosen a pretty guessable password, or one that's actually in the dictionary alone, well, they're just going to get into your account a whole lot faster, a whole lot easier as well. But even then, if you and I are clever, odds are by this point, you probably should just use a simple English word or some other language word or just something that's in front of your desk right now, because rather you should probably be using a password that's a little bit stronger. And that's what I mean. If you use an English password, so if you use a normal password like this, you're still vulnerable. You're vulnerable to something which I call what's known as a brute force attack, which kind of invokes memories of old, where someone might have a big branch or tree or something, or just using it as a battering ram to get into castles from before. But this idea of brute forcing your way in is, in that case too, of something analogously, whereby you're using software in order to digitally try every single possible password as well that exists on planet Earth. Just get in by brute force alone. And so here too, you're vulnerable because if your password's too short, even if it's random, if it's got letters, it's got numbers, it's got symbols, or odds are the adversary, the person trying to get in, also has enough time. They also have enough technical savvy. They could just try every single possible password in the world, and eventually, they might get well into your system. So that's the challenge. Okay, we're dealing with the infinity. How do we go about by defending ourselves from those kind of attacks? We use the passwords. We know we have to get a password. We need to authenticate ourselves to a system somehow, some way. But those passwords, of course, they come in different forms. So it's kind of a low bar that's set actually by a lot of devices nowadays. For instance, if you and your phone, if you'd like to chime in and chat here and just tell me how many digits in particular, how many usually is required of a system in order to authenticate yourself. If you think about your cards, if you think about maybe your fire alarms or something you might have at home, what number of digits do you often have to give to a system to authenticate yourself in that case? Will's going for 4. So Dave lives in a fortress, but usually I think Will's spot on there. Now, I'm glad to see, and honestly, those are the kind of inspiring words that I would hope to see most systems today. But as we'll see, 8 and above seems to be best practice, when in actual fact, we're still kind of relying on 4 digits nowadays. And as is the fact in PIN codes, as is the fact with CVV numbers or CCV numbers or alarms or whatever else. So, okay, well, let me conjecture. I'll come back to those high numbers in a second. But I would say that every time I set up a phone, I'm asked for a password, often like this, or a numeric password, okay, of 4 digits alone. So we absolutely right, Will. Maybe this is kind of invoking people of the iPod generation. Oh, I remember that screen. Yeah, I remember too. But let me propose then, if I have a 4-digit password, a 4-digit password like this, 1, 2, 3, 4, more generally, how secure is that? Let me put it to you. First question then, is it secure? And if so, how much? No right, wrong answer. Let me know what you think. So if you'd like to challenge the chat there, probably not. And it's a fair question. It's one that, has to be asked. Why not that very secure? I'll probably get to the fact, or add to the question then, how do we even go about by thinking how secure the password actually is? 4 digits only is easy to guess. I'm not gonna, so I wouldn't say it's easy per se, at least not, it's what Will says instead. I agree. So let me clear this up then. It's not per se because it's easy, at least, to think up or conjure up a number just because of the pure combinations alone, but it's the combinations. Okay. So, we could start to measure this, and that's what we're trying to get to, just because it's got 4 digits alone. So, not even by using fancy maths, actually, or that password generator right there, we could actually measure the security of a password really just by having 4 digits alone, by considering, well, how many possible combinations are there? And you're absolutely dead on there. How many combinations of 4-digit passwords could we ever get? Robert, well done. That's the straight in. So I was going to say, if you want to chime in the chat and tell me how many possible passwords are in, but Robert's on the ball there today. So it's all the way through. I mean, you tell me. If I say the lowest number possible, so if I have these digits on screen, what appears already on screen, what is the absolute rock bottom? What's the first number we could possibly work with using these current numbers on screen? How many possibilities do we have is the question. Well, let's start from the client. Let's start from this bedpost to that bedpost. It's a little bit more than 10, as we'll see, because if I start, remember, 4-digit password like this, if I say, well, let's start with the absolute 0, so 0, 0, 0, 0, and then we can see our working way through all the different combinations. So 0, 0, 0, 1, 0, 0, 0, 2, 0, 0, 0, 3, and you might be thinking, well, what's the absolute biggest number I can get through? Well, that's obviously 9999. So you're thinking, well, Robert, what are you drinking? It clearly can't be. But yes, there's also, the actual fact that I've got 4 decimal points, 0 to 9, but the smallest number possible, what it come up with, obviously, as I speak, is the 0000. The largest one I could come up with is 9999. You might think, okay, well, that's obviously 999 possibilities, but not quite, because if you include the 0000, that's the 10,000th possibility. So indeed, there is 10,000 possibilities. Imre is right, it's 4 to the power of 4. So if I'm using 4 digits specifically, well, you can think about this more generally like this, which is especially, how we can figure out the maths for much larger passwords, much bigger passwords as well. So if I said I've got, if I'm sounding robotic, it might be the case that I'm far away from the mic. I'm playing around with my audio a little bit too. Just on pause points alone, can anyone else hear me like Mr. Robot, or is it something else? You are hearing me like a robot, yeah? Okay. Let me see if I can go about and fix something. Honestly, I'm not sure if I could. Sure. So that's going to be something on the Zoom side. Microphone. That one. Well, I'm not too sure I can make something. No, same as my system. So my microphone is this one. I brought one just for this reason. So it could well be that we've just got a lot of latency between me and you, Paul. I'm afraid. Maybe it's my voice. Okay, let me slow it down, because let me say I've got numbers. I've got all the way 0 through to 9. So that's the first possible digit, okay? 0 to 9, 0 to 9 on the next one, 0 to 9 on the third, 0 to 9 on the fourth. So all I've got is 10 possibilities. That's 10 possibilities times 10 times 10 times 10, which, like you said, yeah, of course, if you're doing more mathematically, it's 10 to the fourth power, which the exponent being 4, and that, of course, gives us the whole round number of 10,000. So that would be the most mathematical way of approaching it, and versus the most intuitive thing of 000 versus 001, etc., all the way to 9999. Okay, but the question is then for the group, how long, in terms of time, for an adversary, how long do you think it would really take to get into my device? For instance, my phone, or if I have a 4-digit password, anything at all that has a 4-digit password, that means I might have to try as many as 10,000 possibilities on the far end in the easiest case, because, well, maybe shortly to get lucky, or the password is the first one on the list, 00000. Yeah, something's definitely wrong somewhere. It might be with the voice. There just might be a lot of distance between you and me, Paul. I happen to be outside the UK at the moment, and that could just be a lot of latency between us. But just for the time being, I'll slow it right down, and I'll rephrase the question as the time it would take. So, as a question to you, something in between. How long do you think it would take for us to crack the password? Thanks for letting me know, David. So in that case, it might be something on your side, Paul. Move close to the router, Ethernet cable, the usual question, the usual troubleshooting things. If that doesn't work, I'm not too sure if I can help much there. But for the time being, I'll slow it down. I'll say the time it takes to crack maybe 10,000 passwords is, all right, you know what? We can go and figure it out. So how would we estimate? How would we actually go about by measuring the amount of time it takes to get something like this? Well, let me propose then that if I'm going to go to my computer, let me just, even if you've never written any code before, that's fine. We'll go ahead and actually write some code all together and get rid of that. So what we'll do is we'll go over to, oh, God, my Teams messages all over the place. 2 to 3 hours. Well, okay, I'm glad. So I've got some estimations in chat, and what we'll do is we'll kind of work it like this. So what do you mean by a big zero notation? Is it what I'm not too sure. Clear up for me if you will, what I mean by that. Because at the moment, what I'm just saying is I'm just going to try how long it takes to crack 10,000 possibilities, okay? So what I'm going to do is I'm going to go ahead and open up all right. So, I can't zoom any further. Never mind. So I'm going to open up a file. I'm going to call this one file or something or the other, and it really just means to figure out what a password actually is, or to brute force your way in, because what we're going to do is how long it takes for me to get in, okay? So what I'll do is I'm just going to go ahead and, even if you've never really programmed before, it's completely fine. I'm using a software called VS Code, which is a free program essentially that you can use more generally, that allows you to write code in a PC or any internet-based device. So I actually can write code here, and not only just write it, but then run it as well too. And what I'm going to do in this case is write a bit of code in a language called Python. And Python is just a very popular language. It's one that's used all over the place, but it could be one of any hundreds of programming languages out there. So the goal here is not to really focus so much on learn Python. For that we have a whole other class with Rug, but just to demonstrate what an adversary, in that case, what a hacker need do if they want to get into, for instance, your Android, your phone, or anything else that has a 4-digit password. Okay, so my presumption here is that for demonstration's sakes, I'm going to go ahead and write code that prints out every single possible password on the screen, like this. But you can imagine if I had a USB cable, maybe a lightning cable, maybe something like this, I could connect to a phone really quickly, especially if it's your phone I just swiped from a table that cost a coffee. I could quickly put that into my laptop here, run the code I'm about to write, and then automatically send all 10,000 possibilities to your device before you even realize the phone is actually gone. Okay, so let's go ahead and do that. The easy part is I just want to import something called a module. So I'm going to go ahead to a library. I'm going to go to a library called String. String happens to have a lot of those things I'm looking for already, like this. And from that, I'm going to import a thing called digits. Okay, so now it's very easy of giving me access to numbers. Okay, numbers through 0 all the way to 9. I could obviously type them out myself on my keyboard, doing it like a human. It's a little bit faster. Gives me in that case a list of all the numbers I actually really care about. So there's a different there's a whole way of, ways I could write this code, really think about that. But what I want to do is intuitively try all the possible digits for the first value, then try all the possible digits for the second value, all the possible for the third and the fourth, and so on and so forth. The answer is no, we don't actually know how to actually code this ourselves, but I'm just showing you rather instructively, one way of doing this is like this. I'm going to use a keyword in Python. I'm going to do something called for, which really just means to do something for as long as I want you to do that thing for, okay? And then I'm going to give myself a variable. A variable, just like in maths, is just something I can use to keep track of a number, like a thing in my hand, okay? So for this, I'm going to say for a default value, as tends to be the case with numbers like this, I'm going to use the value of I for integer. So I'm going to go ahead and say for that, for every value for each I in those digits, because there's 0 all the way to 9, I want to go ahead and do the following. So colon. Well, for each of those digits, 1, 2, 3, 4 digit string, okay, for the first value, so green, by the way, appears in the comments, which means that it's not going to be run by the program itself. Rather, it's something that you and I can understand quite easily. So this is a comment like that. Point being that I'm just going to give you illustrate the points of how this works. Okay, so I'm going to start by saying for A in digits, okay, as well. So for A in digits, and then for each value, I'm going to say in my placeholder, I might do something like for B in digits, and then lastly as well, I might do something like for C in digits, D in digits. No, I only need 3. Yeah, I'm thinking it's a 3-place text. Let me start like that. So that's fine. Basically, what I've done is admittedly not the best design. And for those that have programmed before, you're probably cringing at this right now about this indentation. Good evening, Paul Bennett. Paul Bennett just joined us, ladies and gentlemen, the man, the myth, the legend. But this idea of indentation is a bit messy, it's a bit cumbersome, and honestly, it's not the best way to go ahead and do this solution in Python. But it's just a simple way, really, of demonstrating, especially if you're unfamiliar to programming, how we can try all the possible first digits, all the possible second digits, all the possible third, and all the possible fourth. Because what I want to do then is now bury this code, is print out the value of I, A, B, and C. So in that case, what I've got now is iteration through 4 different digits, all the values there. Okay, so iteratively, I'm going to see on screen 1 second, if I run this in a moment, all the moments. So I want to be running all the digits 0 to 9, all the numbers, all the combinations, should I say instead, all the combinations of numbers 0 to 9 across a 4 digits space. So bum, 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 like that. I just saw your message there, Paul. Yeah, I had a lovely holiday. If that's the case. We're on the same continent, but I'll see you in a minute, okay? Thanks for joining me anyway. So what we're doing then is kind of estimating, or assuming that you've connected to this phone or whatever it is. Estimation from before, we said 2 to 3 hours. Let's go ahead and actually run the show. So what I'll do is I'll save this file, put the chat over there because it's getting away. I'm going to save that as, I'm going to say this one is crack.py, like that. So that what I'll do now is I'll open up a terminal window at the bottom here. I'll press run. So now, when I run this file, you're going to see a few things happen. You're going to see a terminal window that appears at the bottom of the screen that goes like that. And then right then and there, you'll see all the numbers, combinatorially speaking, going through all the digits. Okay, so there we go. Wow. So that was really quick. 3, 2, 1, again. Right there. That's it. Okay, so for the person that estimated 2 to 3 hours, how close were we really? Yeah. How close were we really with a 4-digit combination? Run that again. Yeah. So how long did that take? And that's pointed out because you said 2 to 3 hours. We're actually a long way off that too. Okay. So the takeaway here at least is that apparently using a 4-digit password is not very secure, obviously, because we can see how quickly you and I, an adversary in that case, a hacker in our story, would be able to get into your phone or anything else. So in fact, I could probably just unplug that in the point because whatever data I've got from your phone, you wouldn't even notice I'm that quick going through 4 digits. So we need a different way of solving this problem, And I propose we do it like this. Just to confirm for me, please, I've gone back to the PowerPoint. Let me know if you can actually see the PowerPoint instead now. We'll come back to the code in just a moment. All right, Daniel, cool. So clearly 4 digits isn't the way forward, okay? So how can we go about by improving the system? Well, let me propose then that instead of going through a 4-digit passcode, so 0 to 9, 9999 being the most, well, 10,000 being the most, and 0000 being the least, which takes about a few milliseconds at most, let's instead use letters instead, okay? And English is the language we speak well, so in that case, we have how many letters, people, in the English alphabet, if those who might speak it? Oh, didn't mean to give it away. 26, Magnus, yeah. And that's it. So, you know what? That might give us initially 26 letters for the first position, 26 letters for the second one, 26, 26, 26, 26. But for that second through to 4, then we propose then that we actually use not just the uppercase letters, that is the case here, but also something else. What else should we use instead? How can we really take this a step further? Lower and special. Okay, well, let's start with there. So Morgan's right. Let's go for the lowercase instead, which is, 26 times 2. That leaves us with 52. And if I do 52 possibilities, that's 52 to the fourth power. So anyone want to estimate just at the moment how many possible passwords that is if I'm using 4 English letters now, uppercase and lowercase? A rough ballpark, any idea? And honestly, any number's fine. Give me an idea, a rough ballpark of where we are with just that figure alone. I can see people frantically Googling, looking for the nearest abacus of the like. Just as an estimate, because what we're doing is we're saying uppercase letters, lowercase letters. We'll come to special characters in the next very slide. But right now, as it stands, I'm seeing 8 million or about there, Darren. Yeah. And not quite as much because we still need to account, we're still doing lowercase and uppercase, but definitely estimates go. Indeed, the lines of this as well, 7 million or around about there. So that's 7 million possibilities from our previous 10,000. You might think, okay, well, that's a big deal. That's surely going to be a lot better. And it is. It's going to take the adversary quite a lot longer to hack into a phone with 7 million combinations as opposed to 10,000. So let's go ahead and do that, okay? Let's go back to the terminal there, and I'll reopen the code file, but let me go ahead and not just use digits, but instead use the ASCII letters instead, which of course is a character set that we'll come across in just a second. So our point before is we use 10,000 combinations, and that's no, not good enough. So what I want to head do is from the same module, actually. It's not important just the digits alone, but I'm going to change this to something called ASCII characters, or ASCII letters. I think that's it, yeah. Okay, so I'm going to go from ASCII letters, and then of course I'm going to replace that here and here and here and here. So they might look a bit jarring at first, and indeed I spelled that wrong. That's probably why. Again, there is another easier way. If you're cringing at this, yes, you could be more succinct. You could be less duplicative, but it does involve some features, and some of the things we'll introduce another day. But what I have now is all my possible ASCII characters. And ASCII, if you're for the uninitiated, looks a bit like this. It's this, the ASCII table, which I know you will use because you use it all the time. Here we go. So I have all the possible ASCII letters from the first placeholder right to the left. Okay, so let me go ahead and open that Python file again. And I'll run this one. Now, to answer the question as before, 7.3 million. How roughly do you think in time, any estimates, how long is that going to take me? So how much time do you think roughly it's going to take now? A few seconds, Morgan. Yeah, Imre, yeah, a few seconds. All right, well, let's run let's do this. So we said 7.3 million combinations of which. Now, again, this is a point of using four digits, or sorry, 4 letters, 4 units of the English alphabet, uppercase, lowercase, and some special characters as own. But by this time, what we're going to see is how long it takes. So if I run this one, save the file, press run, this time looking at the bottom of the screen, it's because it's not defined, because it's not called that. All right, let's try now. Oh, there you have it. Okay, so notice what's happening at the bottom. Let me just make that a bit bigger. So, okay, so from this time we can tell is we're going through the alphabetical order. Okay, the first case, A, B, C, etc. And we're looking at the second one right now. Then the uppercase, then the lowercase, then the uppercase together. So what we're seeing is both uppercase and lowercase together, which indeed in a minute, as we are just doing before, we're going to go through them one at a time. So it really is just going through the fourth digit, then the third, then the second, then the first. But really, it is a lot slower. I think 5 seconds was still too little. And actually, we're going to see that taking a lot less. Oh, I'm getting people fighting over controlling the pen with me. I'm going to wrestle that back off of you. All right, so presumably we're okay, but it's not quite complete yet. And presumably we can even do better. So let's go ahead and take that step further. Looks like minutes, and indeed it is. So actually, by the time we finish it, very good point. Depends on the computing power. I'm just stipulating for the time being we're using my computer, a processor that can found on an end computer like that. But it's not too, a computer which is, by the way, tasked with doing other things too. It's got threads that are running Teams and Zoom and all the rest of it. So if I think about it, if I can put some apart and just solely dedicate itself to the function of hacking, it wouldn't be that unlikely to work through those figures a bit quicker. And that does depend on computer. Absolutely right, Imre. So presumably then, obviously, even though on my computer alone, even 4 letters of the alphabet, even 4 characters in that case, might just not be enough to keep us secure, because we will work through them. It just will take a minute as opposed to a few seconds. So let me go ahead and do what we're actually all told to do nowadays by that annoying voice in your back of your head, which is to go into your phone, go into your tablet, go into whatever device you have in question, and actually use 4 characters instead of 4 digits. Not just use letters, but not just use digits, but also toss in some punctuation as well, use them all together. And I'm glad to see, yeah, Daniel mentioned and Will above. So that's the world of punctuation. At least on the UK keyboard, we can have typically as much up to 94 possibilities for letters and numbers, uppercase and lowercase, and punctuation as well alike. So that's 26 characters, 26 uppercase, 26 lowercase, decimal points 0 to 9, and then 32 other punctuation symbols we can throw into the mix as well, which leaves us with 94, which if I do 94 times 94, 99, 94, better thought of as being 94 possible keys that I can get up here. So 94 to the 4th power. Anyone want to estimate what that is? We've gone from 10,000 to 7 million, so quite a big jump. A rough ballpark, a rough figure. Billions. think, yeah, I think that's, well, yeah, way more. Okay, so we've gone from 10 million to 7 million, and I'm seeing in the chat already. Yeah, three, well, even more than that, roughly 78 million different combinations. So in that case, 10 times more secure from before. So 78 million. So let's go ahead and actually try that out ourselves. What we're doing is now including, look, it's still running, by the way. It's still running from before. We're actually just on the uppercase E, just for reference, but still a lot more to go, I think. No, it might just rerun the whole command again. It just didn't break the loop. Anyway, so let's go ahead and stop that terminal and instead rather go ahead and fix that solution by this time saying I'm going to add or also import special characters. So going back to not just using letters alone, but also numbers. So I'm going to say digits. And let me just punctuation is called. So from a module, I'm going to take those ones. I'm going to put it in here. So not only just using the letters, not just also using numbers 0 to 9, but I'm also now going to use all the special characters you'll find on a traditional keyboard, caps locks, and all this stuff here. I'm not going to do them all because it'll mess up my whole thing, but you have it there. Okay, so let's go ahead and run that. Guesstimation then. Before we said how many seconds. We went from having a few milliseconds to a minute. Now on our third attempt, which is 700 million combinations. Oh, sorry, 78 million combinations. How much time do you think that's going to be the case there? Oh, yeah. Thank you, Will. Terrible. 4 hours. Well, we can go and definitely have a look. So let's try this. This time I'm going to save the file and I'll run the file. And it's actually going so fast, I can't see if it's working or not. I think it is. I can just about make out some crazy, maybe not so much. I'll actually save the file. Just 2 minutes. Save the file. Leave the chat to one side. And run it again. What I'm looking for is I'm trying to look for capital letters, punctuation, all that kind of stuff too. Am I missing something? No, it is there. I just, I think it was running the previous command before I could go into this one right now. So if I do run this one again, some crazy stuff going on here. All manner of things has happened, but it's actually, the point is that we've come into the full circle. We're seeing how many more characters are involved in something like this. So at the time, because we have 10 times as many possibilities from 7 million to 78 million, I had the case with the lowercase e's and everything else. I do have one from before that I hadn't here, so I'm just going to run that one instead, just for the sake of simplicity, just to have that on screen. So you can see kind of what that looks like as it's happening in real time. So, I have E, A's, and then B's, and then that's still going through the lowercase letters, but this time it's a lot slower going through them because it has all that extra punctuation to work through. So it looks a bit like a Hollywood movie in that case because, it's going across the screen very, very fast. It's a bit cryptic at first, but, we're running through all the letters, all the digits, all the punctuation and the like. So it looks a bit fancy like that. Miracle from CSI Miami, Hollywood movies and the like, that even though it looks to be very dramatic, that we go, so it's gone into the punctuation marks already, instead of, we're just doing this, which is really just iterating from right to left very, very slowly, the movies, TV shows, and the likes really just dramatically get maybe this one right and then that one right and then this one right there. And then finally, just in time, you get the password right. But that's obviously not quite how it works because that's not what this is. And what we're doing here is brute forcing. We're trying to do things more methodically, not just jumping around from symbol to symbol, but actually trying to take a long time to try every single stone, uncover everything on the path. So I'm not actually going to finish waiting around for this because I've still got to go through all the other letters. We're only on B at the moment, not even finished through the punctuation. That's easy to say that ultimately those 78 million combinations is actually getting up there very, very fast. So what does that leave us? But honestly, like if I came back in a few moments' time, I'll be finished nonetheless. I'm not kidding. It was so quick, and hopefully none of us has a password. That's only 4 characters anyway, so we'll go on. Odds are, at least conventionally speaking, it's 8 characters. I'm glad to see that's what people were thinking of when I asked earlier. So indeed, that is the case with most websites, most apps, most systems nowadays. They do require that much from you as well. And the maths here is pretty straightforward as well. If you have a total of 94, what happened to my lovely gifts, by the way? Are they not running? Oh, they're there. Yeah. So if I have 94 to the power, so the 8th power, anyone want to ballpark how many passwords are possible now if it's only 8 characters, which isn't even that long, but if you have 8 of them in total, a lot. We've gone from 10,000, so 10,000, 7 million, 78 million, and now kind of to add this into the mix, too much to count. Billions, not even close to think. So let's have a look. So it may look like billions, but I think it's roughly this many passwords, which is a huge amount of, it's actually hard to figure out. So let's see, we have, so 385 million, 689 billion. And this is people. What comes after a bit? So million, billion, trillion. And last one to round it off a good measure. What's the last possibility? A trillion. I think it's just Craig. I think that's right. I had it as a quadrillion, which is pretty out there now. Now we're talking about big numbers before we get into made up stuff. So those are 6 quadrillion. I'm not making them up. I think get someone smarter than me to actually pronounce them, but far larger than I can actually make out. And that's kind of the point. Is we're getting to silly figures very quickly. We're running out of steam. We're running out of energy. We're running out of money. We're running out of application. We're running out of lifetime actually before anyone can actually go through and try out and brute force their way through this many possibilities to try and crack the password of that particular one. So in that case, what we get is a very strong password, and it's that many combinations, so to speak. And you can obviously imagine the time it takes to do that is just unsurmountable. So that's one of our key takeaways, at least from now. When it comes to cybersecurity, when it comes to securing our accounts more generally, it is really this game of relativity, this game of resources too. What we're doing here is not taking something that's fundamentally different by adding numbers, adding digits, adding punctuation and the like. It's still sort of the same formula, the same approach to our password, shall we say, add more complexity, just add more water. But as we make it longer, we're also raising the bar as well to our adversary trying to get in. Why? Because so long as you and I don't do something like really dumb, like just say our password is 0000000, right from the beginning. So long as we're choosing something that's pretty random in this whole string of things, in the 6 quadrillion we have actually available to us, it's going to take the person way more time, way more energy than it would otherwise just to brute force their way into that password. And so by the time they finally, get into the account, then you might have changed the password. You might not be using the account anymore, or you or the adversary, might not be on the planet anymore. Which is, to say this is the goal. What we're trying to do is raise the bar against the expected difficulty of trying to get into our own accounts. And, there is the downside too, of course. It's not all great because, the longer your password gets, the more complicated it is as well. And the more complicated, the more likely it is that you and I are not even able to remember the password in the first place. So here is through that balancing act, we say, between trying to figure out the usability of the password of the account and then how user-friendly it is actually to be used, versus the security of that account as well that you need to put in place. And finding that inflection point is somewhat of a personal, somewhat of a corporate policy as well to do typically. All right, so I guess it begs the question, what can we do to defend ourselves from that kind of brute force attack? So brute force, when someone just tries to get in using all those possible combinations with all the time, all the resources, all the money, all the compute in the world. So at least in the UK, we've probably come across this before. These people, the elders of the internet, they're called the NIST people. So there's an organization in the US, they're called the National Institute of Standards and Technology. They're just a organization, they're a board of the elders of the internet. That's what they are, okay? Otherwise known as NIST. And they just actually issue recommendations about how consumers, how people, how more generally how humans go about securing their own accounts, securing their own safety more effectively online. So what I thought it would be a good thing to do here is actually stop and share some of those recommendations for you, just so that it informs you of your own behavior as an individual person, as a citizen, really, as a consumer, but also if you're in the place of business where you can actually influence your own company's policies, then generally these are considered what we call best practices nowadays as well. So from their own documentation as well, we can look at this. Quote, memorized secrets shall be at least 8 characters in length. So that at least corroborates the quick math we just saw a second ago, and the test we ourselves ran, that once we go up to like 6 quadrillion possibilities, it feels like it's going to take a long time to actually hack into someone's device. So just consider this for your own accounts too, that even on your phones, you might have to go through a few more menu options to upgrade just from 4 digits to something else, but you'll certainly benefit from that additional layer of security. So this one's a bit more of a mouthful, but we'll see verifiers. So the website or the app or the verifiers, that's actually verifying your inputs when you authenticate yourself with a username and password. Okay, so those verifiers, they should permit subscriber-chosen memorized secrets of at least 64 characters in length. All printing ASCII characters as well, and the space characters should be acceptable in memorized secrets. So a few things to highlight: Unicode as well, space characters, ASCII characters and like. So now if you're not a computer person, there's a bit of jargon with this one, but first of all, the key takeaway here is that the websites, the apps, the things that we're using, the systems should let us, should you and me come up with passwords that are typically as far up to 64 characters in length, 64 characters long, which is pretty long, okay? That's exactly the point. How long it is, particularly how it's gotten more difficult for you and I to actually remember all our passwords too, to actually come up with a very complex password. The reality is that you and I would be way better off on the whole by choosing a easy to remember, more down to earth, salt of the earth, longer password that we can, think of instead. For instance, a sentence or a quote, which is what that's trying to, suggest. Where's my pen? I can't write off the page. So, or like a phrase or something memorable like that. So something that you can keep in your human mind, because you don't necessarily have to put a crazy amount of punctuation or digits or numbers or something that's just not materially speaking that human. Okay, but at least is 64 characters in length, and that's so. Even if an adversary tries to get in, if they try to use a dictionary attack, which is trying all the different possible English words or some other language, even if they try to do some brute forcing attack, it's going to take them a long time to go and do that. Unless, of course, you do something stupid like using a 64-character passcode that's only 000 and the fourth. But you still want to be original with that space is what the point is too. So more technically, the recommendation is referring to this, ASCII. So ASCII refers to generally the US English symbols on the US English keyboard, which was the origin of the code itself. So that includes A to Z, 0 to 9, and other punctuation that we just hinted at earlier. So all that today is pointed in ASCII. But there's, why not? I think there's a good point to make this as well. Why not use Unicode characters too? What is Unicode, people? Or what comes to mind? Who's ever come across Unicode? And maybe if you're playing around or fiddling with your app settings and the like, you come across that as better expressed as something else. I'm thinking of examples. Yeah, Morgan, it's an emoji. That's right. So things like emojis, things like so other accented characters like zeros and ones. Okay, so zeros and ones, if they use combinatorially speaking, do form those Unicode emojis, which or other accented characters like a this way, a that way, a this way. So all kind of manner of symbols and things that you in languages beyond English might have. But unfortunately, that's just not very common practice, I dare say, which is, just yesterday I made an account on a new website for the first time, and it made me jump through so many different hurdles. I almost gave up. Just had to figure out the right number of uppercase, right number of lowercase, punctuation, and God knows how many punctuation I'd use as well. But the thing is, I had to think about what symbols I was using too. So there's a lot of friction. Okay, that's not good for usability, and it's of course questionable for the security of the system if me, the human, if I can't remember the actual thing, if I can't remember the thing afterwards, then keep that in mind. In general, that your password shouldn't be used for 8 characters alone. So maybe minimally 8 characters, but definitely as apps, definitely as websites, as the internet grows, maybe as you self-develop apps going forward, should allow for much longer passwords, up to 64 characters in length, and maybe questionable punctuation marks if you so allow it. Bear with me a second. I'm overheating. I'm going to get the fan on. Oof, okay, back. Sorry about that. So back to this. I've got a few more slides to go through before I will do something fun. But so back to the NIST document. These, again, just best practices. Think of recommendations that not, I was about to say AWS wants you to do, but rather what's documented by NIST, so the forebearers of the internet. What they're suggesting is a good practice or more recommendations. So here's another one. Verifies, again, so those are the websites, those are the apps that you and I use. They shall compare the prospective secrets. So those are the passwords that you're choosing, the prospective secrets, against a list that contains values known to be commonly used, expected, or compromised. So that is to say that when you type in a password, if it's already been used, if it's a commonly used password, if it's very easily guessable, if it's something that the website or the app should probably say, pick a better password than that, because that's quite an obvious one. Just to decrease the probability of an adversary being able to get into your account, we would rather refrain you from using that password altogether. So specifically, NIST recommends that we use passwords obtained from previously breached corpuses, which is a fancy way of saying that if some website, some database has actually been involved in a leak before, that your database contains usernames and passwords, and those passwords now have been uploaded to the internet for adversaries and anyone actually at all to find them on the dark web and browse and download and say, hey, I'll take that one and I'll run with it. So you shouldn't be allowed to use those passwords or pick a password from that list, because it's essentially just like an alternative dictionary, but this time it's a dictionary full of already compromised passwords that other people and yourself maybe have already used. So it's essentially just it's a list of dictionary, passwords that a smart person should be able to start with before even bother to resort to brute force attacks like we've seen would take much, much more time. Dictionary words. So we've already said that it would be a good thing to avoid these dictionary words because they're just so easy for an adversary to go through a big list of English words or some other language and just try those first. If you ever hear that, that there's a suggestion to say, okay, find 3 things in front of you: cup, tissue, desk, whatever it is, and then put them together and that's your new password. Don't do that, because that's just, again, using dictionary words, and that's actually part of it too. We want to move away from them altogether, and we also move away from repetitive or sequential characters. So that's a or slightly more creatively, but not good enough, A1 2 3 4 ABCD. I will also add 0 0 0 0 into that 4th category as well. It's just too easy for the adversary just to maybe guess you're doing something repetitive like that too. And then lastly, context-specific words such as the name of the service, the username, and the so that takes a bit of so let me explain. It's to say that if you sign up today for Gmail for the first time, a Gmail account for the first time, which is of course owned by Google, and they allow you to choose a password, you shouldn't be able to say, I'm going to call this one my Gmail password, quote unquote. Okay, so if you sign up to say an Amazon account, you shouldn't be able to call it Amazon password. You shouldn't be able to call it eBay password or whatever it is. Just because someone's going to try the same heuristic as you are. Okay. There is that catch too. I'm just saying, look, if you can think of it, if you right now, as clever as you think you're being, even if you think you're being smart and getting up a hand here, odds are that just as clever person as you has also thought of that heuristic, and they can also resort to that same trick before they actually go to brute force as well. So it's, yeah. A few other recommendations as well. So memorize secrets shall not permit the subscriber to store a hint that is inaccessible to the unauthenticated claimant. Verifiers shall now prompt subscribers to use specific types of information. For instance, what was the name of your first pet when choosing memorize secrets? So there are a lot of companies, a lot of websites, a lot of applications that violate this recommendation nowadays. And in fact, I bet you can think of one or two or more accounts that you've had to tell them, for instance, what was the name of your first pet? What was the name of your first car? What was the color of your, whatever it is, what was your mother's name, your father's name, your best friend, etc., and the like, which is not good to collect either, okay? A hint. Don't, I mean, sounds on the surface of it a good idea, but it's not, because frankly, you and I are too often in the habit of maybe typing into that hint field, if it's available, a question that's designed for us to help us remember what our password actually was. But if your hint is something like, my password is the name of my first pet, my password is the name of my best friend, well, now you're just leaking information to the real world, okay? And anyone who can go online and figure out what that information is can now get into your account as well. It's actually very simple. So then there is that threat as well, is the case. So if you start to use this personally identifiable information, PII, in the age of social media, the age of websites and LinkedIn and the rest of it, there's just so much information out there that can be easily discovered. That's just waiting to be picked up on. So you don't want to fall into those databases, all those systems, all those, with each of those tidbits about you, because a smart adversary would be able to, with enough time, with enough money, enough focus, could probably figure out any and all of those values as well about you. Okay, so one more. Verifiers shall not memorize secrets to be changed arbitrarily, for instance, periodically. So this one too is something that a lot of companies violate nowadays too, as a recommendation, because now if you're in a corporate workplace, if you're actually being required by sysadmins to change your password every month, every 3 months, every 6 months, every year perhaps, that's actually not recommended as best practice anymore. Not too long ago, it did feel like best practice, but it's not actually the case anymore. It doesn't sound like best practice. Why? I'm going to stop there. I'm going to guess. Why do you think that might be the case? Whoops. Where's my Zoom chat? Forgot them. So, yeah, I think it's there and you're right. So why money? Why is it not good practice to it's a really good point, So if I forgot them, it's the point is like if I had the long short of it too is you don't want people changing their often very often. Yeah, because yeah, actually that's very good. Okay, so all of you are right. It's like this. So I'm going to take one suggestion first. If I say where's my pen? If hackers can figure out something about me, if I'm being forced to change my password every month, so every month from July, August, September, and the likes of, so on and so forth, I'm required to change my password by the company policy so frequently that I tend to not exert that much effort when I'm required to actually do so, because we're humans, and we're lazy. And when we're lazy, we take the path of least resistance, and that just means doing the bare minimum just to meet ends meet. So for instance, let me just start with that example. If I say, for today, my password is, so Will's password is password1. Not picking it, and if it is Will, I apologize for leaking that, but assuming you've now been told it's been leaked, it's time to reset it, it's the month of August coming up, well, if you know this is going to keep happening, you might just say, well, I know password, I know my key phrase, I know my word, I'm just going to go ahead and append another word at the end, or letter, or just change the number thereafter. So password 2, maybe in September, do the same thing, password 3, and so on and so forth. So what Will might be doing, again, not picking on you personally, but you might be exerting the least amount of effort possible to just change your password until you meet the company's policy. Again, not too hard for you. You need to remember that password, but the new password is, and indeed, if new information about my password leaks out, if they know, well, I know they just take the same word and change a number at the end of it too, then wait a minute, okay, your password was 123 for the last few months. Let me go ahead and guess that heuristically this next month is going to be 4, and so on. So you might be actually leaking information by doing that too. AJ's absolutely right. So help desk get this all the time. It's the number one thing they do all day. It's just reset passwords and ask, is it plugged in? So if we keep forgetting the password, like Darren says, if we have to get help desk to come and do it for us, well, we might not want humans to actually change the password for us because we keep forgetting them. And, exactly, if you make me change the password too often, too frequently, honestly, I'm probably going to forget it anyway, because I'm going to get confused with my last month's password or the previous month's password or the like. So, and there is that sociological effect that comes into us too, because, us being humans, we're not very good at remembering, not only the first password we made, but the second one. The second and third one also, it's just difficult to maintain. It's why we should come up with such a scheme, like we'll see in a second, to actually help or reduce those adverse effects. So one more recommendation from this alone, which is this, okay? Verifiers shall implement a rate limiting mechanism that effectively limits the number of failed authentication attempts that can be made up on the subscriber's account. So what do we mean by this? So odds are that if you yourselves have probably experienced this, and I think you maybe have, if you forgot your password a few times, or you kept typing it wrong slowly, or your screen was wet, so you're doing it in the shower, or just something wasn't quite registering with your fingertips quite well, you might end up with this thing right here. Okay, come on, who's done it? Hands up. Let me see him. Yeah, yeah, Yeah. Yeah. And honestly, I think most of us probably have fallen privy to this at some point or other, because it turns out you can lock yourself out very simply, out of your own phone, out of your own device. And in fact, you've probably seen this on an iPhone. It's the case here, but Android has the same screen. For instance, if I typed in my wrong password 10 times in a row, or maybe less actually, the presumption made by Google, by Amazon, by the hardware is that, if after 10 times you still haven't inputted the right password, there's a high, probably a high probability that you're not the person who's supposed to have this phone, that you're not you, but rather it's someone else who's taking your phone from you, stolen your phone, and is trying to get into it by just trying random numbers. Okay. Now, that's not always the case. You can imagine situations where you're just being absent-minded, you're probably half asleep or something, and you're maybe not just focusing on it altogether, and you've locked yourself out. And I think I've definitely fallen prey to this a few times. And there is too, again, that trade-off of usability versus security. What am I trading for this and that? The high probability event after 10 attempts wrong probably tends to be that an adversary is trying to get in and not you, because 10 is quite a lot. But what is the point of this too? So beyond just annoying the adversary who's trying to get, this person right here's got your phone, and maybe more significantly, really annoying you when that happens as well. What this actually does is it slows them down more. Yeah, and it doesn't stop them altogether, but it slows them. Unless you want it to be stopped, Morgan. That's a really good point. So in other words, what this does is it increases the cost of the guy here to go ahead and realize this attack. Because why? I mean, we saw a second ago that a smart adversary who knows a little bit about Python, a little bit about code, can actually steal your phone, and they can try 10,000 possible passwords in a few milliseconds or less. So, however, if you try to slow them right down, and having this feature on your phone, on your Android device or the like, that just pumps the brakes, so to speak. When an adversary does try no more than 10 passwords at a time, that's going to significantly slow them down. And that might just maybe spend 10 seconds, and then probably 20 seconds, and then an hour, and then a day, and then, a week or longer, and then it gets into silly figures. But essentially what they've done is just try to increase the time limits or stop them from getting in. So the first time you mess it up, maybe 1 minute, then 5 minutes, then, after a while, and, the nuclear option, like Morgan suggested, maybe just stop it, just wipe the phone altogether. It was a mission. Apple sent me an email after 30 days, reset. I was locked out of, oh gosh, I'll tell you a story in a bit. Yeah, I think after coffee, I'll tell you a story about Google, about how I locked myself out of my account. But long story short is, it's difficult, okay? All right, so, yeah. Again, the right way to think about this is, again, beyond the actual usability or the trade-off, is we're trying to raise the bar to the adversary trying to get in. We're trying to make it more expensive, trying to make it more costly, trying to make it also more risky as well to the person trying to get in by actually purposefully slowing them right down. How about more risky? I say, it's like that Hollywood moment where someone just stolen the phone from your table at Cafe Nero at the coffee shop, and they plugged into the laptop, and they're just trying to desperately crack into the moment right before you get back to the table, because you come back from the toilet and you've got coffee in your hand, and by slowing them down, actually, it's going to increase that risk hugely, to being caught as to the actors while they're doing it. And if they're caught, then hopefully you can do something about that there and then. But hopefully then, too, really is the goal of all of this, is for them to lose interest in your phone, lose interest in your account, lose interest in you as a person generally, because, it's too difficult, it's too much. The waterline is too much, and ideally move on to someone else, or at least, someone else that's not you. No one, if possible. There we go. So I'll just put that on one side. So we left off, we were talking really about the trade-offs about usability and friendliness and user-friendliness, and also the time it takes for you to get into your own systems. Obviously, we have to put up a barrier. This is software. Software doesn't know anything about us humans. How do we then authenticate ourselves in order to then authenticate ourselves to then authorize ourselves to do all manner of things within? Funny thing about iPhones too, I'm not too sure about newer models, but at least I remember a friend of ours who left his phone, and they said, what you do when your kids, and you take their phone and you go onto the camera, because you could do that from the lock phone, and you could take photos without actually getting into the phone. So you could authorize yourself to do things like taking photos, as I promptly did, and took about 100,000 of them, thus rendering the whole phone like unusable because the storage was so full, and they found it less funny than I did. Anyway, so back to this. We want to really consider about defenses and how we can get in from on our side, at least, how to protect ourselves from what I just did, those brute force attacks we've just been discussing all along. So how we can disguise ourselves, how we can protect ourselves from brute force attacks, how we can from dictionary attacks and the likes. So, well, this is for a system that you and I are increasingly able to turn on nowadays. It's now more increasingly being able to turn on as well. In general, probably a good thing, and that's called 2FA, or two-factor authentication, or better known as multi-factor authentication, which is another technology, again, in addition to having one factor that you're able to log in, like a password. As in tradition, you also have a second, maybe a third, or maybe more multi-factors that you additionally have to use in order to log in as well. And that is, it supposes a magnitude more difficulty because they don't just suppose one password or two passwords or three passwords of the likes. They are fundamentally different types of factors. Multi-factor authenticator is generally brought up or thought of as being these three broad categories like this. So, one itself is the knowledge category. So a knowledge factor is something that you, like your password, ideally keep secret. No one else actually knows. And that's why it enables you to authenticate yourself, because it proves that you and only you hopefully have that knowledge stored away in your noggin. Another kind of factor would be, again, possession. So something you actually physically have, something you physically possess and have. So you might be in the habit of carrying around one of those little key fobs or something that has a little code. Actually, there are changes inside, and And they can be pretty expensive, I've got to say. But increasingly, the world is now moving to do things just on their own phone. So you're an Android phone, you're an iPhone phone, you probably one that's got SMS support and the like. So text messaging, or maybe a specific app actually that displays a short code that you type in. But the presumption is that if you challenge the user not only to get a knowledge factor, like a password, but also a second factor, like something they possess, you significantly decrease the probability that an adversary is going to be able to get into that same account. Because whereas anyone on the internet, millions of people can be a threat to you just by figuring out or finding out your password, and get so leaked. But a possession factor really just narrows down the focus or that threat to only the customers in Cafe Nero or the coffee shop, or actually in your own proximity. So only the physical people close to you, because they would actually physically have to obtain that second factor, that multi-factor as well. And the third kind of factor is something that might be called or thought of as being inheritance. So again, that's something that's unique to you, specifically you. That, what makes you? This. Some might be generally thought of as being biometric. So maybe that's your fingerprints, maybe it's your face nowadays. But again, that's something inherent to you. So a third factor nowadays is just a presumption that you and only you have your face. Ideally in the world, that exists as a factor as well. Now, this is a little bit different to what some companies, some websites, some apps might describe as two-factor authentication, where two steps actually might be used as two separate passwords of some sort. But two-factor more technically refers to the fact that two of those fundamentally different types of factors interplay with each other. Okay, so being the most common case in our scenario, the ones on screen here. Then when it comes to those possession factors, those key fobs or the apps or the codes that you actually receive, they specifically, what you're receiving in those models is known as a one-time password or an OTP. And the idea of an OTP is that it's not just a password or something and keep remembering and using again and again and again. It's literally just a one-time password, because it's texted to you, it's sent to you by an app or a push notification or the like. It's actually sent to you on a keychain, like in this key fob, for instance, right here. So nowadays, your company can actually buy them from Amazon or the likes, just from a normal shop. And what happens is, like you see on screen, I've got a one-time password, and it's constantly changing that number every couple of seconds or so. And that's now synchronized somehow with another server off-site. The presumption is that I'm carrying around this device. I've got it in my pocket or so on. So I type it in when I'm prompted to type it in. And that particular code, that particular second for like 30 seconds expiration, if that matches the synchronized server or the code of the server, then I too should be allowed into the account, because the presumption is that it is indeed me carrying around this device, not necessarily someone else who's got hold of it. It would also be possible to put it in with USB, like we see right here. So other technology like RFC or whatever it is, you can just put your phone to it. But thereby, what we're doing is trying to remove the human formula from the device itself, so that we can authenticate ourselves using special software on the system instead. Nowadays, though, probably more commonly, more easily, you can download apps from Google, other companies, Authy, Google Authenticator, Microsoft. They all work fine. Honestly, there's minimal difference between them, but they're all just allowing you to manage all in one place all of those one-time passwords that you might automatically see updating on your screen. So you can type any of all of them in when you're actually prompted to by a website or an app. Okay, but even in the space of one-time passwords and possession factors, it's worth keeping in mind that there are some of those technologies that are more secure than others. Now, it's scarily common for websites and apps nowadays to want to send you some of those one-time passwords by a text message, for instance. And so you receive your one-time password via SMS, by text message, and you can actually type in that 6-digit code, often, as is the case, 6-digit one-time password. But more secure, though, would be something that an actual app that you install from the App Store, from the Google Play Store, the like, that actually talks directly to some server and doesn't go over the phone network. Why is that? Well, as you might know, your phone is actually typically a SIM card. There is a SIM card or an IMEI number, a physical card that actually has a little chip inside. Nowadays, might be actually built into the phone itself as well. But that SIM card itself has a unique identifier. And so when you go to BT, you go to E, you go to Orange, the like, and you sign up for a phone service, so a phone plan, typically that company, they need to know what that unique identifier is. They keep that on their own system, on their own database of your SIM card. So be it something physical, something actually hardwired onto your device or whatever. Why? Because as they associate the phone with the phone number for that specific device. The catch is, though, that it's all too possible nowadays, in some cases, all too easy, actually trick even the phone providers, trick O2, trick BT, all those big companies, by swapping my SIM. Not actually doing it physically per se, but actually convincing the mobile phone carriers to actually update their own systems and say, oh, well, Marco now has this SIM card instead, not that other original one there too. And that is to say then that I'm an adversary, that I have any other old phone with any old SIM card in. I can figure out what unique ID is, and maybe I can call up that person's phone provider, and somehow I convince them to say, I'm Marco, I'm someone else, by tricking them into believing it's me. Okay, as I'm telling them all of my personal information about myself, I might be able to convince them to swap out my SIM card altogether, the adversaries with my own, to what's already on file. The implication there is that when that person subsequently gets their text messages, gets their one-time passwords, they actually don't go to that person straight, they go through me. So I'm the hacker in this case. They've gone through my phone as well, because I'm now being tied to that particular SIM card, because I got the phone provider convinced in that case that was me. So in general advice nowadays, if you have the choice, if you have to choose between a website or an app to use an SMS-based text messaging service versus a native application that can support, you can install it into your phone or some other device, you should generally prefer the latter in that case. Some first-class bit of software that actually sends you push-based notifications of your data plan, not just relying on SMS, because SMS is a unsecured, it's not a secured network per se. So what other threats does it exist when it comes to your systems? Well, it turns out it's also very possible, unfortunately, for adversaries to somehow get software, malicious software, as it's known, otherwise known as malware, onto your Mac, onto your PC, and even onto your phone. So that might be because you installed a bit of code, a bit of software that you actually shouldn't have trusted to begin with, for any number of reasons. So maybe your phone, maybe your device is infected, maybe it got stolen, maybe it got anything at all. It got a worm. In general, though, what you might be vulnerable to malware, including software that logs all of your keystrokes. So key logging refers to exactly just that. It's a piece of software, most likely there maliciously. It's going to be literally recording every single thing you type in, everything you type into your device. And what that software now does with the keystrokes, very often, it's going to then upload them. It's going to send them off to some other server. If there's an internet connection, if it's Wi-Fi enabled, maybe that server is being controlled by the hacker in that case. Okay, so the implication of the keylogging there is that if I'm typing in my username, as is the case there, that's okay. It's not that big of a deal because, generally speaking, usernames are public. If I'm typing my password, though, well, that's bigger of a problem because if that's being automatically sent up, like you see on screen here, to the server, whatever that is, and now they know username and password, worse actually is when they see you typing in your one-time password, your 6-digit code or whatever it is, as it's being received even from your phone or some other device. And if they're fast enough, they're smart enough to actually figure out how to log when you're typing, send it to the server, perhaps even before you actually yourself hit the word end, and then maybe they can use that only your username and your password, but also even including that one-time password, pretending to be you on their own phone, pretending to be you on their own laptop and desktop on the right. So actually automatically having software that goes in and types in those values and accesses your account even before you yourself had a chance to do so as well. So that's very difficult to work with. Now, we don't have good, what defenses do we have against this? It's kind of hard. Really, just generally be paranoid. Be very paranoid about what computers you actually use. For instance, nowadays I'll rarely actually use an internet cafe. I saw one the other day. It boggles me how it's still a viable business, but don't use one. Don't use even a public PC in a library or the like, just because you don't know how safe they really are. You don't know when it comes to best practice. I don't know how. I don't know what they're doing basically. And if you don't know what they're doing, that is enough to be a healthy amount of skepticism is all we need. Okay, I'm only going to be generally so. Only log into websites or apps or my own personal devices on your own computer, which is to say that, I'm not perfect. I'm not going to do that all the time, but at least I'm reducing the probability that I'm going to lose control over my data by using some other device that I don't actually oversee in person, which is to say that owner, not me, themselves might not be adhering to best practice, and I just don't know. Now, even then, I'll admit, by using keylogging and getting up to adversary server and inputting it faster than you and I might be able to do so, it's a pretty straight, it's a very difficult target. But it's worth keeping in mind that it's possible and realizing that those are certainly theoretical attacks. And if you yourself are behind a targeted, if you're being targeted for whatever reason, those are absolutely things to be mindful of. So in general, if you have the luxury of only using a device and not some shared device, that tends to be best practice, I would say. So what other attacks can we be mindful of? This one has a bit of a funny name, but this is one that's known as credential stuffing, like a big turkey. And we've come across that reference before in this discussion thus far, which is credential stuffing. A credential is something like a username, like a password or the likes. It just refers to the process of a hacker, having found a whole bunch of usernames and passwords, maybe online, maybe on the dark base or something, but in a database that they or someone else has attacked and posted for the whole world to see and download. So credential stuffing means not just using dictionaries, not just using brute force alone, but literally using a list of already known username and passwords, maybe from some other applications, some other websites, to try and actually pigeonhole them and stuff them into different websites to see, well, if Marco's using this username and this password over here, with high probability, with probabilities also using the same username and password over there. So credential stuffing is a threat, I dare say, that many of you probably are vulnerable to doing as well. Now, you don't need to raise your hand in admit to doing it right now, but if you are using the same username, if you're using the same password on 2 websites, 3 passwords, 30 websites and the likes, you are today vulnerable to this kind of attack. And to be clear, like if any of those websites is compromised, as does happen if you can go to websites and have a look, have I been pwned, etc., they could figure out all the usernames, all the passwords on that system. What a smart person's going to do now is try to use that same username and password they found for you on Amazon and try it again on Gmail, try it on eBay, try it on any other website, try it on any other app that with some high probability you might be using just because those services are so popular. So what's the takeaway here? Ideally, if you want to be immune to this kind of credential stuffing attack, when someone does take credentials over here and tries them over there, you have to use different credentials. That's the only way around this for each and every website on each and every app. So you should not be using the same password on multiple websites and multiple apps. Username, yes, especially if it's your email address, that's fine. But passwords, no. Now, this is admittedly easier said than done, and we'll see very soon how we can try and achieve this, but avoid credential stuffing, by having unique passwords, at least having some help when it comes to managing some of those as well. But there's another attack as well that comes up indirectly here and there. It's known as social engineering. So social engineering isn't a technical attack per se, but a social one, a sociological one. It's one that attacks humans, the brain. So let me go ahead and suggest the following. Okay? Just to make this clear, you probably have come across this in some shape or form. I know you have. But if you have got a piece of pen and paper, I don't want you to put it into the chat per se, but if you have paper and a pen on your desk right now, I want you to go ahead and actually write down one of those passwords you talked about before. Any code, so any password at all you could possibly think of. Go ahead and write that on a piece of paper on one of your passwords. Any of them is fine. We just want to go ahead and actually write on paper in front of you, write down one of your passwords, and we'll see what we can do with that today. Okay. So if you can, let me know. Give me a thumbs up, give me a reaction if you've done that. If you've actually written down your password on the paper, including if it's got punctuation, if it's got digits as well, even the better. All right, you've got your password in front of you, yeah? Okay. All right. Maybe some of you are wearing a bit trip. You've got some resistance going on. Prince, iPhone 15 Pro Max. I'm afraid to say you've all been duped. All right. Okay. So it's exactly the point. I'm sorry to say. Why would you take my suggestion? Don't listen to what I'm saying. Don't write your password down. Okay. Don't write it down on the paper. Even though I'm presumably, I'm someone you should trust, I'm telling you to do this in the cybersecurity class. Those who have reached for a pen, those who have reached for a pencil, just wrote down one of your passwords on a sheet of paper were just, I'm afraid to say, socially engineered into circumstances that were created because you trusted me, you believed me, and I was asking you or telling you to go and give something. And, if you look at the face value of what you should be doing, you shouldn't be doing that too. So I'm sorry to say that's just how simple it is. And then moving forward, if anyone does ask you or write down your password on a piece of paper, just one takeaway from today, at least is, just don't do it. That would be social engineering. And in general, if someone does call you on the phone and say, they send you an email, try to get information from you some way or another, even if it seems okay and legitimate and all the rest of it, moving forward after today, especially, have some healthy amount of skepticism about it. So I was hoping to see some resistance. And if you have, just have from this point onwards enough paranoia to be healthy in the interest of protecting your account. So moving forward, if someone does ask you, even on something a little bit more nefarious, trying to figure out what the first pet was, whatever it is, that kind of information, your ears should be perking up. Your spidey senses should go off in the context of Spider-Man. You should be wondering, wait a minute, why do they need that information? How does this play out? Try to figure it out before you actually give away anything about yourself. So indeed, if that was you, bless your heart, thank you. But, if you did actually write down your piece of paper on your password with a pen and pens, just remember that feeling of being duped right now, because we do not want that to happen when it actually matters. Okay, so after this, I know you'll believe nothing I say, but go ahead, shred up or tear up or flush whatever piece of paper that password has on it too. The point is not to share it with anyone, just to prove that particular point. There are so many scams today. Find them on YouTube. There are, I don't know what the phrase is, baker's dozen, but you can find, they're very crafty, very, very crafty. You alone may be thinking, okay, I'm probably, but it's often not you. It's often just trying to find the low-hanging fruit, I'm afraid to say. They try to go for people that probably don't have the best instincts when it comes to cybersecurity. They probably are more susceptible to attacks like this. Scammers will, they're casting their net wide and far, not really caring now, going into too much detail. If someone, I can't remember the name of him, but there's a guy on YouTube who calls up these scam centers, talks to them through a woman's voice or puts on the voice of the elderly, sometimes a man, sometimes a woman, and he just wastes their time. If you know who I mean, he's quite famous nowadays. You'll know exactly that person, that character. He's brilliant at what he does. So that's a bit of reverse social engineering happening. But social engineering really is beyond that. It's just preying on, mind instincts, which is kind of fun, but also very dangerous to think about all the ways, all the avenues you could go down. Now, there's another threat, another variant of this too, which is more technical in nature, still on social engineering, which is that of phishing. Now, most of you probably have heard of phishing in this context, of emails, but you can think of it like physically going out fishing, trying to hook a sucker, someone like me or you, who was duped into providing information that they actually shouldn't be doing in the first place. And that is often very much the case with emails. So odds are, if you go through your spam folder, so you'll see emails that seem to be coming from PayPal.com, seem to be coming from Google.com or anything else the like. But those emails often encouraging you to go ahead and click on a link, make a donation, click a link, maybe change your password, click a link, maybe verify some bit of information. And that phishing is trying to get social engineering in that case in a more technical way to convince you through very convincing looking emails like this, even websites that actually look legitimate, they look real, they look like they're from PayPal, they look like they're a real email from AWS or look like a real email from you and me or whatever it is, but it's not. Congratulations, exactly. What they're trying to do, adversaries in this case, is, wow, bait you in with the congratulation, something alluring, they prey on your trust for those certain companies, certain trust, certain instincts, certain people. They're trying to prey on your comfort, trying to prey on with those familiar user interfaces, things that you've seen before. But unfortunately, it's just far too easy for an adversary to make a very official looking email, especially with the age of automation now and so on, to make a very real, legitimate looking website, or one that looks just identical to PayPal.com, identical to Gmail.com or other services. And frankly, if you take some of the course as well, it really just boils down to copying and pasting the simplest of scenarios, just copying and pasting some legitimate website's code and pretending that you own it as well. So how might phishing actually manifest itself in the real world? Well, consider one of those, like you said, you're right, those, so congratulations, you won a thing, or we would like to invite you, or have you checked out this thing, or maybe something more, a little bit, one of those social media posts that I think you all know what I'm referring to. They try to invite you in, they try to comment you out, so try to ask you to something, or I've seen them on Facebook too. Facebook always asks for stupid quizzes like, what's your what Disney princess would you be? What's your favorite song? What's something from your favorite child? Completely mind rot, I'm afraid to say. But sometimes those posts have millions of responses somehow from people that you know and maybe people you don't know. But more than that, it's being interested in what your childhood favorite song is. Maybe those posts are often fishing for personal information, because suppose that you, or at least someone else among those comments, is actually using a favorite childhood song as an answer to a website or an app or a secret question as a hint. Then now the author of that post, and not to mention everyone else, also knows the answer to that as well. Yes, and I'll take that a step further. Well, there's a great case study on a malware. It's called Coopface. So it's just Facebook in reverse. And the history of the Coopface is absolutely fascinating. The way that it was, we still don't largely know who was attributed. So some of the people got away with it, and it was based on affiliate marketing. It was a worm that was infiltrating systems. It was then duplicated itself, and then it was sending itself out with a fast flux IP address, which means that it's very, very hard to track down and see where it actually came from originally. But it's like crazy. Yeah, the best we can do is just be mindful of those kind of things too. Just use skepticism too. Unbelievable. If it sounds too good to be true, chances are it probably is. Like this, and case in point. Okay, so how can you know? How can you tell this apart? So this might be Magnus's email address right now, I'm afraid to say. So if you're trying to visit your own Gmail later, maybe your inbox folder, your spam folder looks a little bit like this. So this is Gmail's login page. At least in the UK, I've been using this. And frankly, I've seen this so many times that I'm just inclined to blindly type into the form my email address and blindly type in probably after that my password. But it's important to then develop an intuition or a suspicion that those websites might not be legitimate. Okay, how might you go ahead and do that? Well, you should minimally be looking down here at the left corner, the URL. So you maybe make sure that the place that you're actually going to is actually gmail.com or probably google.com or whatever google.com code you're actually looking for, depending on where you are in the world, of course. But that making sure that that's actually the legitimate looking one, that you've actually been there before, perhaps, or when you actually hover over the link, you can actually more common in your browser look at the bottom left-hand corner and see where that link will actually redirect you to, like Imre suggesting, absolutely right. But then again, trade-offs, Imre. Like, even though the words on screen may say something, the actual link here, it's something else. Okay, it's a dark alley, and God knows what happens there. So even then, it's actually hard to tell or discern those kind of things better. Even with these are just best practices too. You don't have to be so worried that you actually stay still and never go anywhere online, because you'd be paralyzed and you can't go forward. But you should at least keep an eye out for those kind of things. And in general with phishing, rather than actually trust anything, and websites have been getting a lot better. Sorry, Gmail inboxes have been getting smarter at both not displaying content and warning you about the links, saying that this is an untrusted link, unverified profile, and so on. Anything that you receive, especially if it's something private, like a bank account, something medical, something personal, well, okay, if that's the case, if I do need to go ahead and do that, don't click on the link perhaps, but then, if you know what it is, open up a new tab and manually go to that place instead. Manually go to PayPal, manually go to the whatever it is, okay? Just don't trust those blindly links itself at face value. Now, again, we see a trade-off between, like I said, usability and security. It's a bit annoying if I can't click on a link that's right there in blue and I very easily just go to the place I want to go to. I had to now manually stop and manually type in the page and so on and so forth. But then again, it really depends on what's more important now to you, the usability of that service versus the the security of your account therein. This is a bit more worrisome when it comes to those two-step verification codes, and Google does take some liberties when it comes to the wording here. Usually best described as a two-factor authenticate, 2FA. But again, even the most sophisticated of adversaries, theoretically, if they send you a phishing email, they've tricked you, they duped you into visiting a website that looks like Gmail, but it's actually not Gmail, they could theoretically even prompt you for a two-factor code, much like this. And then if they're smart, if they're savvy enough at code, they could actually now automatically send your username, send your password, send a two-factor authentication, maybe to the real Gmail, log into your account, change your password before you even get up and running therein. And that's a more sophisticated threat to really push you out of the boat altogether. So it's not something you need to worry about as much, but it's a principle of not trusting screens and requests that are presented in front of you so easily. God knows what happens. So Facebook, I don't know if it's me, but Facebook Marketplace has done a full circle. It used to be terrible. It has replaced the Craigslist. I think all the people from Craigslist have now migrated to Facebook Marketplace because I don't know, but there's a whole there's a whole subreddit called Delusional Craigslist ads. And if you're interested in that kind of thing, I'd go ahead and suggest you Google that and find out yourself, because it's funny. The kind of people out there, they're crazy. The buyers are scammers. Yeah, they really are. They're just looking for information. They're phishing. They're targeting. Oh God, it's even worse when it's properties too, or renting. They're just time wasters above all else. So you should have some healthy skepticism. Okay, you should know how to decide for your at least for yourself. Yes, I'm comfortable with proceeding with this step and beyond. I can't say no for everything. Eventually we have to move forward and learn our lessons the hard way. So there is another kind of attack too, and that's more sophisticated than not the one that you need to worry about so much, not so frequently as the other ones, but they're generally known as a man-in-the-middle or a machine-in-the-middle attack, whereby if you're on the internet, there are, suffice to say, many other machines on the internet very often between you and the website or the app you're visiting, many hops in between. And often those machines might be things like routers, they might be servers that ISPs, they provide, or maybe your own home owns and then controls. But all that data is often passing through those machines in the middle, so to speak. So if any of them are malicious and any of them are maybe storing your data, it's very possible that you might not be having a secure you might be having an eavesdropper, okay? And they'll be focusing in on when we talk about data, but we'll talk about cryptography some other time. But it's worth knowing that this general idea that it feels like it's only you and some app and Amazon.com, or you and PayPal, you and the website, but there are other machines, other things in the middle, something that's called a ARP poisoning attack. And they take advantage of the SYN-ACK response between TCP packets. So if you're not keeping best practice on this too, if you're not keeping an eye out for those things like access points, if it's free, unsecure like that, probably not best to go into your PII website, your personally identified, not leak information online by going to sensitive places like that on coffee shops and airports and the like. I know it's boring. I know you've had it a million times, but it is actually, there is some logic to that too. Especially since I think last year or this year, there was a few devices that TikTok has got a hold of. It was called, God, what was it called, people? The thing with the duck that TikTok all of a sudden got a hold of, and everyone went crazy about it for like 2 weeks. It was before the rabbit. It was a Flipper Zero. That's what it was called. So with someone with relatively little experience from Cybersecurity could actually get hold of one of these devices with a few pounds and start hacking with just a few YouTube videos. The barrier to entry to hacking has never been lower. To take your data, to access your data, to then access your accounts, and then do something more with that as well. All right, so I hope you can see that there's a lot of attacks out there, and by this point you're probably feeling a bit defeated. I'm sorry to bring you down on a Monday night, but hopefully you've also presented at least defenses thus far, and there's still a fair few more to come. But now let's consider how to source a lot of these problems too. Unfortunately, it's you, okay? It's not you, it's me, it's us. It's the humans, okay? The whole story here has decided, we started today with you and I are not very good at choosing our passwords. That's the long and short of it too. Generally, we want to meet the minimal requirements, take the passive resistance because we're lazy, not necessarily the best practices actually altogether. But again, those are those sociological effects of corporate policies or technical policies to induce that kind of trade-off too between security and usability. So Paul's asking, is it possible for someone to clone my phone, whereby I send a message to someone in the contact, the recipient receives something completely different from what I sent? Absolutely. So just from the previous example, when we talked about the SIM swapping, if I, considering Paul, so you're with O2, take for example, I convince O2 using social engineering techniques. I say, look, my name's Paul. I can prove that I'm Paul because I know this about Paul, and I know that because I've checked you out on LinkedIn. I know that because, we've talked before, etc. So without you knowing, I'm kind of doing reconnaissance missions about you to then convince the third party, a network provider in that case, to then set up my phone card, my device, my actual MAC address with your particular SIM card. With some effort, yes. But there are more sophisticated attacks. So sniffing attacks or packet sniffers could also be done. ARP poisoning is really clever. I'm not too sure with phone technologies and carrier networks because I just don't know the technology well enough. But largely, I would say yes. Simply because the way that the phone carrier networks, when Edison and the likes, the people thereof didn't really have security in mind when they were designing the phone network. Largely in part, it's just sending SMSs out there. And what we know about SMS is that it's actually not encrypted. A topic which I won't go into too much here, but it's safe to say that there is no obfuscation, no scrambling of data happening between the sender and receiver. Anyone who's kind of in the middle of that, so to speak, can actually catch privy of what's being said and then somehow redirect that or rephrase that or manipulate that in some way. If you like that kind of stuff, Paul, I recommend watching Mr. Robot. Mr. Robot is it's sensational. It has great episodes, very like-minded episodes on that kind of stuff. Yeah, let me link you up. Nice, thank you up. So it's a type, isn't it? Oh, that's over LAN, but I know SIM swapping. Probably suggest those Flipper Zeros I was talking about before. Anyone can get a hold of one of these and then redirect your on AliExpress for next to nothing. That's not pounds, it's another currency altogether, so it's very, very cheap. It's marketed as a way for geeks. In actual fact, it's more, hacking SMS without knowing exactly what you want to do, but there are hundreds of many tutorials out there too. So turn your Flipper Zero into super secure, so a two device. SIM only. I saw the video here where hackers use the jam to open and unlock cars. I don't want to click on the link necessarily because I don't know what's going to be in there, but I'll risk it just for the sake of arguments. Yes, it is in Portuguese, but I want a video. I don't know how TikTok works. I'm a boomer, 100%. I'm looking for one in particular where someone tries to hack into a Tesla. I've seen that video before, surfacing Tesla. So they lock particular cars. And you can imagine if they can play around with radio frequencies, it's very possible then to stop a message in its tracks.
Flipper language is 433.90. Record and save log code as well. Modern accounts are using rolling codes. I will not accept same code twice. Be careful.
All right, it's possible to do. It was big on forwards. It's not uncommon that cars have always been a bit like prone to these kind of attacks, but it's always about raising the bar to entry. Now, there was a time of old where it was actually had to get physical access in. Now it's less so. Now it's more digital and like everything needs an app nowadays. But beyond that, they actually have some kind of file to be stored. Okay, I'm gonna wrap up the discussion here. I know kind of I want to preach about passwords, use password managers, etc. Some of the devices that you can actually get a hold of to prevent yourself from those kind of defenses are things like SSO. So a solution might be this single sign-on SSO or identity center, as it's known in AWS. So single sign-on refers to the ability for you to sign up, log into one website when you already have access to another website elsewhere. So very often the account that you're going to be using is one of the big ones, Google, Twitter, and the like, and one of the most popular websites of the applications out there. So for instance, if you were to log into this representative website right here, now, what you see is, like a form field where you can type in your own email address, your own password to log in, or if you prefer, log in with Google, log in with Facebook. And you and I know that's 9 times out of 10, that's a lot easier. I'm not interested. I just want to get in, okay? Any number of other services that could be listed above that's supported by those identity subscriber, identity provider. Now, the motivation there is that it's still backwards compatible, so to speak, with this very familiar approach of letting me just register with my own email address and let me come up with my own password and let it be done with it, especially if I don't use Google or Facebook as a customer. But the upside there of offering these solutions is, especially for popular websites like Google and Facebook and like others, is that if I already have an account with Google and Facebook, and let's be honest, I think it will do, then hopefully I should have a good enough password for both Google and Facebook and the others because those are important to me. And better yet, I ideally have two-factor authentication enabled on one or either of those. Because again, they're so important to me, those accounts. It wouldn't be nice to just set up a new website for me. So I just log in with my existing account, log in with Google, log in with Facebook, so I don't have to waste time signing up for another, another internet account. And then secondly, because I don't have to remember, I don't have to set up a new one, I don't have to set up a new password. That's another thing for me to then, I don't have to remember that either. It's going to have to be difficult remembering every single thing out there online. So that does decrease friction in some sense. It increases the flexibility of the system because, frankly, just the security overall of your system in that case as well. Why? Because if you're doing a good enough job of protecting at least those most valuable assets, those most personal accounts, then the website stands to benefit from the same best practices you've done retrospectively. You should literally be redirecting your browser to google.com, facebook.com, or any other of those domain names instead. And then you'll type in your username, type in your password, as is usual for Google. But that password isn't given to the identity subscriber. It's not given to the third party. It's not given to the place that you're visiting, rather than a technique used as cryptography and encryption is some fancy math essentially, and a token. That username which you log in with is sent back to the third-party website, but not your password. Just a confirmation that yes, I actually logged into Google and I trust Google. Good question. Is it not good to stay signed in on some of your devices? So if you can trust your device to begin with, yes, 100%. What we're doing is protecting accounts, and accounts, by the long and short of it, you're going to go to sleep tonight, you're going to wake up the next morning expecting to then find your data then intact. Wiping your account every day, every month, every day would be quite cumbersome for you to go ahead and actually log in and then have to remember subsequently every single login you have. So staying signed in might be better, but actually moving the goalpost might be more suggested. Instead of having to remember 100 different passwords, have one password. When I log into my computer right here, I'm signed in on all my things, but I have one password. So I sign into my computer, and then my computer, be it with signature patterns, with fingerprinting, and the rest of it, can then get into those accounts I need to then they're in. I'm automatically signed in. So single sign-on is that idea. Have one account used across many places. So saving passwords on the device, potentially, yeah. Making it much easier for you to register for subsequent actions if you have a device like something like this. I mean, ultimately, that leads us to this discussion here of password managers too. If you're thinking on those lines already of password managers, you're absolutely right. Because you're probably thinking, well, a password manager, okay, you've probably seen, what's a password manager? I want to emphasize probably this one the most out of everything today, because increasingly best practice is a bit of software that that manages passwords for you. Thankfully, there's going to be even a better solution than this on the horizon, something we'll talk about soon. But for now, at least minimally, if you're not using a password manager, you probably should be. Okay, so if you're using the same password on multiple sites of your applications, if you my mom up to very recently who was doing this, you're very vulnerable to credential stuffing. I'm not kidding. Go to a website called I don't think we'll have time for that, but that's a fun one to check out, by the way. Very fun one. All we need to do is, you've probably seen this already, you type in a password, and then it tells you, okay, uppercase letter, special character, 25, 6, April. So you try to get, very soon this will get ridiculous. You should multiply to 35. So 1, multiply to 35. That's 1. X is 10. So I don't know. I honestly don't know. The long and short of it is that the thing, I think I have an account from earlier. I was doing it today with another class, but very soon you can see just how silly it gets. And this is from an attempt we made earlier today in class. It gets to like here. Okay, so you have to go, you have to find a country, you have to find the leap year, you have to then find the best chess move. And after that, we just got complicated. We just said, you know, I can't be bothered anymore. But yeah, so passwords do get very complicated, which is why we can turn to a password manager. Because honestly, if you go to things like have I been pwned, which is a bastardization of the word being owned, which is another way of saying have I been duped. If you put in your email address in there, be my guest, have a look, and you're probably likely more than not been found in some kind of scandal. I've been bloody leaked by the Portuguese airline TAP. They were subject to ransomware a few years ago, and I know now that my password and my other bits and pieces have been since leaked. So thanks a lot, TAP, Portuguese Airlines. So the way around this, obviously, is not by giving them the passwords, but rather storing it on a password manager, something instead that holds onto it on our behalf. So something that can remember the passwords for me. And if you're in the habit, like me, of using very easy passwords, it's just better for you to remember. You probably start using password manager because beyond just having to remember your own passwords, these password managers also make it easier to generate new passwords for you. So you click a button, literally just essentially generate a password on the fly. So however long, however short you want it to be with some uppercase, lowercase, symbols, numbers, and like, it generally just makes it for you right there and then. And better yet, after it's generated the password for you, it stores it. So you, the human, you don't need to memorize that. So you can stay signed in. And then you, the human, don't need to then write it down on a sticky note or post a note or any of the other place they're in. So password managers literally just do that. They have even more features than that. You have paid products as well. But generally, if you're just using a password manager and they're free, you should do. You go to a website for the second time, the third time, you typically just hit an automatic keyboard on the keystroke and it'll just fill that out for you. So it'll fill in your username, your password. But better yet, it'll actually do that on only the real gmail.com. Apple products do that. They're really good for this because they'll, you know what? So I don't have it, but I've seen the password managers on Apple products. They'll remember the URL that you created along. So just like this picture here, it knows that password only belongs to a particular URL, Uniform Resource Locator. So if you somehow are subject to, you know, a phishing attack, if you're being redirected to a place that isn't actually the legitimate place, you're being tricked into clicking a link and going down to a rabbit hole that looks like Google, but actually isn't, that password manager will ignore your keystrokes. It'll actually not log you in at all. It'll prompt you saying, that's not the place that we were expecting. It doesn't recognize the URL structure at all. So that's a good reason why you should be choosing that on top of that as well. Should be a little bit annoying to type in because you don't want the adversary to get access to your passwords and everything else. But it is just one password that we should be asking everybody just to pick well, use it for your password managers, and then reasonably long enough that they're protecting everything else therein. Thankfully, nowadays, yeah, we've got those are the standard third-party tools, options you can find pretty much anywhere online that you can purchase. All right, so I think the key takeaway there today is, you know, should be that if you're not using password manager, it's probably start to use one, probably time to do so, at least for your most important accounts. Okay, things that are particularly personal, medical, financial, anything that you and your family would really be upset about if they were somehow compromised. Okay, at least figure out how to start migrating those kind of accounts to the password manager and then enable some other best practice on top of that too, like 2FA. Or better yet, don't enable 2FA. Don't use SMS if you can. Use a native application on your phone like Password or Authy or Microsoft Authenticator or a physical key fob just to decrease the probability of those threats. So I would encourage you to, just because, you know, it's one thing to sit down on a session like this and just be like, oh yeah, I should do that. But then it feels like so much work to do to go ahead and change hundreds, thousands of accounts. And again, just take baby steps. Bite off the easiest, do the most important accounts first, and then over the next time you log in to that website, okay, well, go ahead and change the password to something better. Put it in the password manager and be done with it too. Yeah, I mean, the next time you go to another website, just do that one. Do those things incrementally, baby steps there too. With that advice, I'm just trying to get you, you know, personally strike that balance between usability and scalability, because if your takeaway is I have to go ahead and do 1,000 passwords tonight, you're not realistically going to go and do that, is it? Just chip away the problem over time. I'm going to wrap up there too, Michael. So I'll just say, you know, it really just does. You caught me in the last slide as it is. So I'll round it off there. But just to better understand this stuff too, we'll need to know a little bit about cryptography, encryption, the likes of it too. But hopefully that's just enough to get you started with understanding your accounts better and securing your access in. All right. Well, I look forward to a nice discussion. Hopefully next time we'll talk about more interesting tidbits too. If you want to find out that website with the password managers, be my guest. They're a lot of fun. I think I'll be trying out that myself this evening. But to all the people in the session, thank you very much, Ian. Thank you, Esperance. Thank you, David. Thank you, Andrew. Thank you, Daniel, Mosa, Darren, Boren. You've all been fans. Thank you again. Those participate. You know, when you actually participate, it makes it 100 times easier, so much more engaging, and makes my night the validation that I need. So thank you for that.